Hi, Mick McQuaid here to finish up the material from last time. The place where we left it was in the middle of this section 1.4, but I'm going to go back to the beginning of 1.4. So the first thing is a discussion of categorical variables followed by a discussion of numerical variables. And so geom bar is probably the most frequently used plot in this class because you have mostly categorical variables except for duration of response time to complaints. And you will become familiar with the forcats package, f4dsCh01conclusion package, which includes functions like this that you can use to order the bars. There are actually other techniques for ordering bars. This is just one of many. And it's covered in chapter 16 of the book, and we'll be discussing it in more detail later. Now, I mentioned histograms. I think this is actually where we ended up, was discussing histograms. So the question was, how many bins or how wide of bins should you have in histograms? So we can set the number of bins either with the bin width argument or the bins argument. So the bin width argument tells us how many items will be in each bin. Or does it? No, it's not how many items are in each bin. It's how many x variables will be in each bin. And here we did it with bin width of 200, so we go across 200 x variables here, from here to here, 200 x variables from here to here. I think in class I said items, and that was wrong. Here we have a bin width of 20. We go over 20 items, I'm saying it again, 20 x variables to the next one. And here we've gone with a bin width of 2,000, so we go from probably, what is this, 1,000 to 3,000, I guess, yeah. From an x variable of 1,000 to an x variable of 3,000. So the question is, which of these is better? And it varies from histogram to histogram. I would say in this particular case that this is the best one. In this particular case, this one is informative. This one is probably more informative, but it's I find it a little harder to read. We can also do a geom density plot, and here I've also said the na.rm equals true, which I mentioned in class as being useful for getting rid of messages like this. Now, the exercises, how does this differ from previous plots? They actually just show the code in the book. They don't show you the plot, and so you have to run the code to see that it's a sideways bar plot. So what we've done is, instead of having the first one be x and the second one be y, we've explicitly mentioned that we want y and not x. So another thing we could do instead is let it be x, go ahead and let species be x, but then add a chord flip function, and that will flip them. And notice it appears the same way. We could, of course, do the FCT underscore infreq the same way. Okay, so how do these two differ? So here's number 1, and here's number 2. And once we actually run them, it's incredibly obvious how they differ. So color is just the lines, the outlines, and fill is everything but the outline. And of course, you don't even, if you do fill, you don't even need, the outline can just be blank in most cases. So I rarely use color for geom bar. Color is useful for geom smooth, but not so much for geom bar. I should mention, this is pretty important. I've specified a color for all the bars here. You might want to specify the color by a variable, in which case you would not put it in quotes. You would, and it would be in an AES parenthesis. Okay, so I've already said what the bins argument does. It controls the number of bins, and the default is 30. And we could also say bin width or breaks instead. Here we've said bins. And I actually don't even remember what the question is here. So we have 3 different ones. Oh, I think the idea was what's the proper number of bins here. And here we have 50, 100, and 1,000. And I think 1,000 is far more informative because you can see the curve here. You can't see the curve in these things here. What happens is there's exponential decay as we decline from values that people like, of diamonds that people like to sell. This is the diamonds data frame, and people like to sell, quarter carat diamonds, half carat diamonds. What is this? A 2/3 or 3/4 carat, a single carat. The 1 carat diamond is a popular item, and we go with exponential decay until the next plateau where a lot of diamonds are sold. Okay, and then this plot contains, and all of these plots contain some items here that are really invisible, because this is 2,500. So if we have 1 4-carat diamond here, there isn't even going to be a dot here, or 2 diamonds there. So it's not, this plot is squashed to the left. So what I've done here is filtered the diamonds by only having carats less than 2.5 carats. And that makes this exponential decay much clearer than it is in this. It's kind of compressed in this. So this is my favorite of these 4. Okay, now we'll go on to visualizing relationships. So far we've been talking about visualizing visualizing a single variable, I guess. Is that right? Yeah. A numerical variable or a categorical variable. So what if we want to visualize a numerical variable and a categorical variable together? And by the way, the ggplot cheat sheet is really good at categorizing plots like this. The plots are all categorized by how many numerical variables, how many categorical variables you have, and so on. And one good way to do this is a box plot matrix, or a box and whiskers plot matrix, usually called a box plot matrix. The original name was box and whiskers plot. And these, which are also called hinges, are used to be called whiskers. And let's see, yeah, this matrix is good. I used to use violin plots a lot. I don't use them anymore. I think a box plot with an overlaid scatter plot is more informative. So that's what I'm doing these days. And what is a box and whiskers plot? Okay, so the box plot visualizes a distribution of numerical data. And the box plot matrix obviously adds a categorical variable to that so you can see the difference in the numerical data distribution among three categorical variables. And the box contains 50% of the data. 50% of the data goes from here to here. So you can see that this one is much more compressed. There's a much more dense amount of data in here than there is in here. It's more spread out here, and it's most spread out here. And the middle line is the median, the heavy line in the center. You can actually make a box plot with the mean as the heavy line, but it's traditional to use the median, and so that's the default. And then these lines, these two lines that form the edges of the box, are the 25th and 75th percentile. So you can call this the middle two quartiles. And you can also say that this distance from here to here is the interquartile range, or the distance from here to here is the interquartile range. And these whiskers or hinges are 1.5 times the interquartile range. So all the data that's 1.5 times from the interquartile range will be held in here. And then any outliers are represented by dots. Now it's much more likely that you're going to have outliers here because the interquartile range is so small. So the smaller the box is, the more likely it is that you're going to have outliers. But it just depends on the distribution of the data. And I should point out to you that when we do statistical tests, which we're not going to really be doing in this class, but you'll often in real life do statistical tests of whether the differences between two categorical variables are statistically significant or not. If you can draw a horizontal line between the boxes, the difference is significant. So there's all your tests are going to show significance. So this is just a handy shortcut to know you're not going to find a significant difference between these two, but you will find a significant difference between either of them and this one here, because you can draw this horizontal line that doesn't intersect any of the boxes. And here's what I meant about overlaid scatter plots. So this is an overlaid scatter plot, and you can see that the distribution is wider here than here. Hopefully you can see that this is more dense toward the center and this is more spread out. And what I've done to do this is added a geom jitter, and I said width equals 0.2. So this width is the width in which these dots can be jittered. So if I don't include a width argument, the dots could come out to here or out to here. They'll be 100%. This is 20. Well, that doesn't make sense to me. I don't know. I don't know actually what the scale is for this number. I just know that 0.2 is a good value for it. I don't like them to come out to the edges because then they get too close to the next box plot. And then alpha is a measure of opacity. So I think this is in percentage, and I think this is 30% opacity. So these dots are somewhat transparent, and I like them to be somewhat transparent. If you have a lot of points, you should make it more transparent. I would typically go to 0.01 if I have an awful lot of dots. Then I can see the density better. And the jittered points are not the same as the outlier points. So this jitter is a completely separate function from the box plot function. And
unknown caller.
Sorry about that. Let me turn this off. This dot here represents this dot here. These are the same. These are really the same dot as expressed by two different functions, and the same thing is true of this here. It's not that there are two outliers down here. the box plot function generated an outlier on the dot, and the geom jitter generated one that's somewhat removed from the dot. It could be the case that there is another one under here. Geom jitter is a stochastic function, so there's a random amount of noise added, and it's possible for a zero amount of noise to be added. And I already said this. Okay, so here's a density plot of the same information. So you can see how different the density plot is from the box plot matrix. I think it's less informative, but the book shows it to you, and you can see that the chin strap penguin is taller and narrower here, which corresponds to the smaller box here. Okay, if you have two categorical variables, I don't like this, by the way, but this is a very common thing to see. The reason that I don't like this will become apparent in a minute, but let me just show you how you do it. So if I say I want a bar plot of island with position fill, and by the way, this is the default, so I could leave this blank, just say geom bar, and I would get this. This is a bar plot of proportions. So on Torgerson Island, 100% of the penguins are Adelie penguins. That doesn't mean that there are the same number of Adelie penguins. This is why I consider it misleading, because this doesn't mean that there are the same number of Adelie penguins as there are Adelie plus chin strap penguins. This is just another 100%. So a little more than half of the ones on Dream Island are chin strap penguins, and somewhat fewer are Adelie penguins. And then, of course, the Biscoe Island has mostly Gentoo penguins and a few Adelie penguins. And that's all the information that we get there. We can get more information by doing the following. I'm going to say stack instead of fill, and I get a stacked bar plot. I think this is much more informative because it tells us, for example, we can easily imagine these three being over here in one bar. It tells us that there are more Adelie penguins than there are any other kind of penguins. You know, that the Adelie penguins would come up to about here, whereas the Gentoo penguins would come up to about here, and of course the chin strap come up to about here. So this is the stacked bar plot, I think, is much more informative. I've also, by the way, used the R color brewer set of palettes here. Color brewer palettes are useful because a lot of experiments have been done with them that show us, let me just show the color brewer palettes. This is an example of them on the R Graph Gallery website, and these are all the names of the palettes. I've used blues. Where's blues? Yeah, blues is right here. I used this palette here, and it selected the colors automatically from this palette. I could specify colors in this palette, but it's easier to just specify the palette. And this is usually used for continuous variables. I've used it in this case for categorical variables. This is usually used for categorical variables, and this is used for diverging continuous variables. But you can use them as you wish. The R color brewer package is named after what is her first name? I forget. Professor Brewer of Penn State does experiments on how people perceive colors, and she has done really extensive experiments showing that. In fact, let's just briefly look at her website. Let's see, it's just Color Brewer. Will take us to her website. She's actually a cartographer, so this is intended for maps. So here are all the Color Brewer palettes. And what she does is experiments where she asks people quantitative questions about choropleth maps. So choropleth maps assign a color or some variable to a region and use that coloring to tell us something about something quantitative about some statistic concerning that region. So if people answer correctly, then she deems that color combination to be a good one. If people tend to answer incorrectly, then that color combination is a bad one. So she's done really extensive experiments and come out with these various color patterns, and lots of other software projects have adopted these colors as default colors or as optional colors, such as the R Color Brewer package, because it's known that they are psychologically relevant to what you're trying to do. So, I went to the wrong place here. Okay, here we go. Let me get rid of the all that stuff. So I think the Color Brewer colors look better than the default colors in general. And I've also added the theme black and white to this because I don't particularly care for the gray background. The gray background is an artifact of print media. So on a printed page, the gray background helps make the graphic be differentiated from the usually white printed page. On a computer display, I think the white background actually works better. And there are other backgrounds you can get too. So I said theme BW for black and white. There are plenty of other themes you can get. Some of them resemble the themes of prominent publications like The Economist, or prominent or projects. For example, there's a project called Solarized that makes color combinations for to make it easier for programmers to work, and you can get a theme Solarized also. There's a theme Tufte to make it look like the books of Edward Tufte, and so on. Okay, and then if you want to do two numerical variables, it's very typical to do a scatter plot, which we've done plenty of. And if we have 3 or more variables, we want to add shapes and colors or size to them. So this is a full. Oh no, this isn't a full. Previously, we did a full specification of this plot. If you have 3 or more variables, it's very typical to do faceting. So I've said flipper length, body mass, and species for each one, and then to divide the plots, I've said use island. And I could overload this. I could actually use this, use one of these on here, but it wouldn't be as useful. This is more useful. So this is really good if we have a lot of variables. And we can do either 2 ways to do faceting. Facet wrap, which just does as many plots as there are values of this variable, in which case this is only 3. There are only 3, but if we had more, this would wrap around and we would get a list of plots. On the other hand, we can do facet grid, which is always a grid, which always puts one variable on one axis and one variable on the other axis. So we can make a larger grid, but we always have to have 2 separated by a tilde. We Always have to have two variables separated by a tilde. Okay, so here's some exercises. And the first one is the miles per gallon data frame that's bundled with ggplot. Which variables are categorical? And one thing we can do is read the documentation by saying $MPG. How can you see this information when you run MPG? So one thing you can do, what I like to do, is STR, structure, stands for structure. And this tells us which variables are categorical. Unfortunately, by default, they're character variables. CHR stands for character. You see that none of these are factors. We would have to actually manually convert all these to factors. We would say manufacturer gets as factor manufacturer. And that can be tedious. Okay, make a scatter plot and then map a numerical variable to color and then size, and then both color and size and shape. How do these aesthetics behave differently for categorical versus numerical variables? Okay, so here's the first one, highway versus engine displacement. And highway is the gas mileage, so you would assume that a smaller engine, so a displacement is the size of the engine, the size of the cylinders in the engine, how much water they would displace if you filled the cylinders with water. And you would expect that the larger the engine, the poorer the highway gas mileage. So you expect this kind of inverse relationship here. Now, if we add color and map it to city gas mileage, we get a spectrum of colors, and there are many different colors shown here. If we map size to city, we get a range of sizes, and there are, of course, again, many different sizes here. These are just snapshotted. If you actually were to measure these, you would find that there are quite a few more sizes represented here than are represented in the legend over here. And of course, we can do both. We can map both size and color to city gas mileage, and then we see that the ones with the best city gas mileage are both large and light colored. But we could instead map color to a categorical variable like drive. This is whether the drive is front wheel, rear wheel, or four-wheel drive, four-wheel, front wheel, or rear wheel drive, and then we just get different colored dots. What happens if we add a third variable to line width? So the first thing here is I've added line width to drive, and it says here using line width for a discrete variable is not advised. So that's a problem. Nothing at all happens, particularly because I've said geom point here. Now, it's still not advised if I add a geom smooth, but it will work. It says don't do it, but it will work. So what's happened here is I've gotten a very thick line for rear-wheel drive, and a very thin line for four-wheel drive, and a medium line for what's the one that's left? Front-wheel drive. Okay, and by the way, it's using this method for geom smooth, so I'm getting a statistic. You know, this thick line thickness is a statistic of probably the mean, or maybe the median. I don't know. You can always look it up. Geom smooth has lots of documentation. Okay, so here I've put line width to be city mileage, and what's happened is that line width has been dropped because line width, if line width is city mileage, it's all these different things. It would be, the line width would be different for each observation. So how could we make line width different for each observation? So line width has just been dropped here. And what we could do is add a group aesthetic or convert a numerical variable into a factor. I think what I've done here is convert it into a factor. I've said as factor city, and boy, it sure doesn't like this. I get 50 warnings here. Or no, I get more than 50 warnings. I get as many warnings as there are points in here. I think only the first 50 are displayed. But in any event, what's happened is that it's binned as many as it could. It couldn't fit all of them, but it's binned as many as it could. So I get a bunch of short lines here, by making it into a factor. And I could do other things. I could bin them differently so that it would work better. But this is not an advisable thing to do. Okay, what happens if you map the same variable to multiple aesthetics? So I've mapped drive to both color and shape here. So four-wheel drive is both this hideous salmon color, I don't know what you call that color, and also round. And rear-wheel drive is square and blue. And front-wheel drive is both triangular and green. So this kind of redundancy or overloading of the variables with aesthetics is often desirable if you want to persuade somebody of something, or if you want to emphasize some point. So here we're really emphasizing the fact that front-wheel drive vehicles tend to get better gas mileage than others. Make a scatter plot of bill depth and bill length and color the points by species. What does adding coloring by species reveal about the relationships between these two variables? Okay, I think I forgot to do faceting here. It said also do faceting by species. So this is actually better than faceting by species. So it shows that they're grouped differently. If I facet by species, I'll see these three groups in three separate plots, but it won't be as obvious that they don't overlap very much. And is there anything else I should put down here? Yeah, several times I've used this colorblind scale. I really like this scale because, what is it? I can't remember now if it's 5% or 15% of males are red-green colorblind. But a lot of people are colorblind, so it's useful to do that. That's also, by the way, why I do these things in HTML, because it's easier for blind or low vision people to read HTML than it is PDFs. I used to do PDFs. I like PDFs better personally, but they're harder for screen readers to follow. Although that may be changing with Gen AI tools to interpret PDFs. So I may go back to PDFs. Okay, why does the following yield two separate legends? So we've got two separate legends here, and you can see that one of the legends has species in lowercase s, the shape one, but the color one has it in uppercase because we've added this thing here, and instead of specifying the variable species, we've specified a character string of species. So ggplot interprets this completely differently than the variable. If we want to do it the same, we have to enclose this in an aesthetic and say color equals some variable. And then we get the desired effect of having color and shape in one legend. Okay, what questions can we answer with each of the following plots? So I've already revealed my dislike for this particular kind of plot, and I've said what it can reveal, which is the proportions on each island. So we can, what is the proportion of different species of penguins on each island? That's the kind of question we can answer. And what is the proportion of islands for each species? What is the proportion of island representation for each species? So we see that Adelie, which is of course the most prevalent, is represented on all of them, whereas Chinstrap and Gentoo are each only represented on one island. Okay, we're coming to the end here. Stick with me. So we can save plots with the ggsave function. The most recently generated plot is saved. So for example, we do this. This particular plot isn't saved, but this plot, which is now the most recent one, is saved. We're saving it as a 7x5 image. So I now have, in the current working directory, I now have a file with this name. Now, this is not that important to me because I would rather you use Quarto, which will automatically generate the plots. I do not want you to save the plots for turning in. You may like to save plots to compare them or something for your own purposes, or to put them in some kind of other document. But in this class, I don't expect you to ever use this function. And here's, oh yeah, you can also save the variable to a file. So I haven't mentioned this to you before, but this arrow, the gets arrow, can go at the beginning or it can go at the end. So I think it's a little confusing to tell you both of those things. So I haven't, but the book does immediately go to this. But so I would go P gets, the gets arrow, then penguins, and then all this other stuff here. That's how I would normally do it. And if I say it at the end of the stream of commands, then it's also saved to a variable. And then if I and in this case, it's not displayed. It's not immediately displayed. Now it's displayed when I say P. When I mention that variable, it's displayed. And so I could say ggsave P as a particular variable saved to a plot. Okay, so here are some common problems that will finish us off here. I've already mentioned this in class, but the plus sign in ggplot has to go at the end of the line, not at the beginning. It's really common to fail to match parentheses and quotes. It's also really common to fail to open an R chunk with to close an open R chunk with 3 backticks. That's a common mistake. When you render Quarto files, the error message can help you find where the mistake is, because it will say quitting from lines 100 to 105. That means there's a chunk there and there's something wrong in that chunk. So that helps me find the problem when you present me with problems. And when you do report problems to me, I want to see the file containing your code, not a screenshot. The screenshots that I get from students usually fail to include enough context to help me debug the problem. The problem is rarely where you think it is. The problem is usually happens before it shows up as a problem. And that's true for all kinds of problems that people run into. Okay, so that's it for the rest of Chapter 1 of R for Data Science. Thank you for your attention.